Hello everyone, it's Peter here, Piotr Fisner. How are you doing, guys? So, in today's episode, we've got a pure sine or pure sine wave inverter DC to AC. That's 12 volt to 220 to 240 at 50 hertz. Now, it's really loud. It's really loud. You don't want to buy it. If I would score it 1 to 10, whereas 1 is the worst, it's the loudest, and 10 is the brilliant, then that would be 1. Definitely that would be a 1. Its proper power, or it's written here, it's 500 watts. But to be true, it's struggling with anything above 100 watts. Similar to what I have here is 500 watts. Only that one is quieter. This one is really loud. So pretty much you don't want to buy it like ever. The only positive side is that this has a display. That's the only positive side, and nice color maybe if you're into it. I'll open it. Okay, I'll open it and we will see how it's built. But before I'll do it, let me just switch again back to the screen and I'll show you. I paid for it really cheap, £23.14, and I've placed my comment about it. If you'll go scroll down, it will be my comment, somewhat double comment, because I did place, don't know if it's first or last, PL UK. You see additional feedback, so you can find it. Yes, that's me, and I will hold to this because it's really pathetic. Now, if you advertise a product as a 1000 even peak, which I can agree that you can have, you see, continuous power 500, that's a-okay, okay, but you should be able to carry those 500 watts. I've even thickened twice my cables and I've made 24 volts available in this room here, and so only I've got buck converter to make it you know, just smaller here, not elsewhere. And then I've got those clips as well, as they are here, you know. So yeah, I would say that, you see, and that's showing, yes. No, the inverter voltage must be consistent with the battery voltage. Inverter voltage is DC 12 volts, then your battery voltage must be also 12 volts, otherwise the inverter will not work or damage. So I've tested and it's okay up to about 14 volts. Beyond it, yes, beyond it, it will show you that on the display that it's too much voltage, but it just doesn't want to work and it's just beeping. Yes, so I was checking, maybe I will put just on the edge like 14 volts or something, but it was still the same. Yes, so you could hear the beep. That's it. Now I can't, yes, I can't say that I can do any better with it, because I took 4 millimeters or 4.5 millimeters from the speaker, stage speaker, like really thick, and even those don't work, and I use these clips which are shown here. Only my ones are goldenish. So I can say it's all this more of a this color, like here. Due to the high input current of this type, it cannot be connected with the battery. Yes, you see, connected with the battery clip, so it needs to be fixed with the battery clip as shown on the left. And I agree with that, you know, I agree with that, but it's not, you see, it's, look, this one 12 volts, 24 volts, 1000 watt up to 2200 watt standard configuration can use those clips. Yes, that can use these clips. And guess what? Yes, guess what? I wouldn't say it's accurate. If you want to carry 2200 watts on the 12 volts, that's too many amps. Too many amps, and these can't carry it. I would say that's exaggeration. Somebody should rethink what they are writing here, because they are lying. Okay guys, so it's recording for 5 minutes. Let's stop moaning, let's get back to work, and let's go and let's check how it's built. I'll make this like that. I won't be putting DSLR, no point. I will open it and I'll unpause, because what's the point for you to watch me unscrewing things. Okay guys, it's already quite interesting. The transformer is just slightly bit bigger than my 500 watts, yes. So the only thing what I will be doing is I will be trying to now charge one of my batteries, because I need to go through that buck converter to get that power. And I would say that the only thing what I could improve here would be to use only the battery. So I'm charging my batteries tonight from the main batteries I have, deep cycle ones, downstairs, and I will be testing it tomorrow. So we'll be straight to the battery, because on the first day I was able to run my computer off this inverter. It was super loud, yes, but I was able to run it, and it was on and off, and my computer is showing 80 to 100 watts of usage. So I would say that the whole culprit behind it could be those clips. I would say that this can carry up to maybe 10 amps, maybe, but 12 volts times 10 amps, that's 120 watts. And the momentum, the computer when starting can take, you know, much more than that. Maybe at the very start can take like 20, or I don't know, I'm just guessing, you know. So maybe when the batteries were fully charged and the connection was robust, then maybe that was the case why it did work. Okay, so this is not a really build which is superb, you know, comparing to any other build out there. I don't see here anything abnormal. There is a controller here. Controller is different than the one which we are aware, like EGS002. That's different. There's one fuse as well here. I think I'll take a photo or a few photos and I'll share the photos with you. Okay, there is a good comparison. If you will look at the fuse on the left hand side of the transformer, you can see how big fuse is, and that's not super big, yes? So the transformer is not that high in the parameters, for sure, yes? That's why I would say it can struggle even with those 500. But again, hey, there's many factors and I'm not expert in it, but from my experience, if you will hook up these cables properly, by look of them, you know, here you can see how many, let's say, max current they might transfer. They might not transfer more current, and then this won't get max current. So that's ideal circumstances maybe, but I would say no. Now these are 25 volts and 2200 microfarads. This one is 450 volts and 47 microfarads. Now this controller, hold on a sec. This controller, it's nothing like EGS002. It's a different controller. That's another board with a beeper here, bridge rectifier, something, or just 4 diodes. Maybe controlling those LEDs as well, this board. So it's a bit of modular. I've took one just so that we can clearly see the model, yes, and then decided to do all of them. So we see all of them on one side, and then we see on the second side CAF 10 and 50 and CAP 120 and 06. Yes, so we can see what they've used here. Good to know. If I would keep it like and use it, then I will probably buy them as well to have them. And that's at the bottom. It's quite thick to be true and supported by solder on top of that. That's why, you know, I would like to check if this can carry more current. To be true, what I need in this room here is one inverter which can serve my computer, because my audio goes from the batteries straight away. So probably, yes, probably what I will do is sorry, mess. Now you see, this is the 1000 peak, this one is the 500 watts peak, so twice bigger is this one, not this one. Can you see? It's much of a difference, like a lot of difference. If this one is a peak 1000, you know if it will carry peak 1000. This one is a peak 500 watts, yes, and from what I know, these cores can go up to 500 watts if you will do everything the right way. So this is on the EGS002. Yes, EGS002. Yes, that's the one which I've built. I didn't have a fan, I didn't have all those connectors, so my plan was to get these connectors and fit it into this enclosure, but it won't fit. When it came, I checked the size and I said, wow, I didn't look. If I would see the size over there, I would not buy this one. So yes, to be true, I'm wondering what to do, because these boards, yes, these boards are the same on the side, they are the same. The only problem is that even if I would insert it here, yes, even let's say I can insert it, because I can, I know I can. Yes, look, that transformer is on the side. So Electronoobs, yes, Electronoobs, when he was designing it, he didn't think through a few things, like placing these here on the side. That's not a good thing. My bridge rectifier is bigger than designed at Electronoobs as well, so that's another pickle for me. Okay, so that's again doesn't want to go. And then again, I can't use it because you see, oh no, that still fits. So maybe, you know, maybe I could use this enclosure to put the shock absorb these, and then something here at the end as well. But for me, yes, for me in person, why he did the capacitor, electrolytic capacitor, close to them? Yes, it's working for the video to have views, but you know that MOSFETs are getting a lot of heat, and why you would put electrolytic capacitor just behind it? This design, I don't like it. I didn't know what I'm doing on that time, so I bought these PCBs. Just I wanted to, you know, to learn, and I've learned from it, so that's a good thing. Whereas here you can see that capacitors are not on the side of the MOSFETs, and MOSFETs are on the side so that the enclosure can absorb the heat. So I need to move one capacitor on that one, put it into some enclosure. I'm thinking about a bigger fan, like the PC fan, 12 volt PC fan, and I will be measuring temp and usage of the power, and I will be using probably that inverter. but this one is okay for small things. It can serve me for, well, I don't need for soldering iron because I've got now 24 volts in the batteries here, so I don't need 24 volts. So my soldering iron will be okay. What else do I need? Bench power supply, one thing. Microscope, second thing. So I could use this. Well, actually no, I've got that blue one, which is quite quiet and which serves okay for those purposes. So this one for now is useless for me. So I can use this and this, but the fan needs to go out. It's too loud, yes, and I can use those to that one. But really, 1000 watts, guys, waste of time, waste of money. Don't buy it unless you wanna have experiences. I will use some components of it probably, and I will keep it on a side. I will learn about those MOSFETs as well, because I don't know these MOSFETs. You know, maybe it won't be that bad. And yeah, and I will focus whenever I'll finish the tidy up what I'm doing right now in the workshop, because already I moved a lot of mess. I'll show you. See, this one, I'm finishing this one now, but these ones are tidy, just that I need to move stuff, and already I start to put customer stuff over there. So the first one is going, and I've tidied up over there beyond the racking. That's why the batteries are not here on the path, which is great. So I would say about a week or two, and I will have more time and more space here, and I can go back to the inverters, and then I will focus on doing it, because I'm really annoyed, you know, with those cheap ones. Literally, don't buy them. Don't buy them. These cheap ones are bad. And what's worse, even those about 100 pounds, 150 pounds, those can have the same build as I showed you. One big one, red one as well, big one, 2000 watts or something. Pathetic, guys. It's just a waste of our money. Good ones are like Victron Energy, yes, for instance, which cost far more, but you've got toroidal inside. That's why I bought toroidal transformer, custom made, and that's why we're going to build something which, one, won't be as loud as those, two, will be pure sine, three, will be robust, four, will be open sourced, and will be silent. Yes, because I want to run it the way that I need to use 0 to minimum of the fan, but I won't be using on the full power of the fan to cool out all the time. That's how I want to build it in a half bridge topology. So that's all I wanted to show you. Those cheap ones will be cheap and will be serving you for small appliances. If you want to use them for something, you know, which consumes more power, you might be struggling, literally, and I'm not even joking. So I want to find one decent high frequency, and I haven't found it yet. For now, I'm giving up on buying them, because it will be just waste of time, and all I want is to build one and be happy this way, because I can't be happy with what I bought. Yes, thank you guys for watching. See you in the next video. If possible, let's fix them all, or design them all in this case, and see you in the next video. Bye.